Alright guys, in this video we are going to discuss macro versus function templates. Why we prefer function templates over macro in C++. This thing we will discuss in this video. So the function templates that we have discussed are used to make generic functions that can work with any data type. For example, this function template is used to calculate minimum of two values of any type. Here we have defined a template, right, which will calculate minimum of two values of any type, and this template we have discussed in our previous videos. However, this task can also be performed using macros, that is a facility of C language created with preprocessor directive #define. So to calculate minimum of two numbers, we can write macro as follows. This will work same as that of the function template. On calling this macro using these two statements, it will work same as that of the function template. First statement will return 20 as 20 is less than 25. So minimum of these two numbers is 20, so it will return 20, and in second case it will return 20.4. So it works fine. So one may think it is better to use macros rather than function templates, right? But in C++, function template is preferred over macros due to following reasons. First reason is no type checking is performed by the compiler in a case of macros, and the preprocessor dumbly replaces any call to the macros with their expansion. In contrast, in function template, full type checking is performed by the compiler. For example, if we invoke macro using this statement, here you can see A is a character and 30 is a integer type, right, number. So it involves values of different types. Then the compiler does not perform any type checking and compare to unrelated values of different type. However, in a case of function template, the above function call will generate an error as strict type checking is performed in a case of function template. Now, second reason is that is the another drawback of using macros. It can cause unexpected results. The first line of this we can understand with the help of this example. So here we have said that it dumbly replaces any call to the macros with their expansion. This thing we can understand with the help of this example. Here we have defined a macro that calculates square of a number. So this is the macro that we have defined. Here if we call this macro using this statement, we expect that first of all this expression will be evaluated, that is 3 plus 3 is equals to 6, and then square of 6 will be returned. But in this case 15 will be returned. This is the actual output, and 36 was the expected one. Why? Because in a case of macros, preprocessor dumbly replaces all the calls to the macro with their expansion. So here x will be replaced by 3 plus 3. So here 3 plus 3 into 3 plus 3. There is no bracket, right? So here this leads to this expansion, and as we know, precedence of addition operator is less than multiplication operator. So first of all 3 into 3 will be 9, and then 3 plus 9 plus 3 is 15, because associativity is from left to right. So 3 plus 9 is equals to 12, and 12 plus 3 is equals to 15. But in a case of function template, such unexpected results are not obtained, because in a case of function template, first of all this 3 plus 3 will be 6 expression will be evaluated, and then 6 into 6, that is 36, will be returned. So you can write we would expect it to generate output 36, right? But actually it generates 15 as the output. It is because any x in the macro body is replaced by 3 plus 3, leading to the following expansion, that is this one. So, but in a case of function templates, such unexpected results are not obtained. So thank you so much for watching this.